Dear students, greetings of the day. We are present here to discuss one more important concept in functions, that is the recursive function. Now, what is a recursive function? It has a very simple definition which says a function calling itself is called a recursive function, or simply calling a function from the definition of the same function is called a recursive function. This allows the functions to be repeated several times since it calls itself during its execution. Functions that incorporate recursion are called recursive functions. Recursion is often seen as an efficient method of programming since it requires the least amount of code to perform the necessary functions. However, recursion must be incorporated carefully since it can lead to an infinite loop if no condition is met that will terminate the function. Calling a function from the definition of the same function is called recursive function. We will see one example of recursive function where a function is being called from the function itself. Let us consider a small C code which is calling its main function explicitly from within the main function. In the main function, one statement we write is as printf start. Next statement, I want to call a main function explicitly, and of course, first time the main method is executed by the operating system, and the second time we are calling the main method. And next, we are writing one more statement, printf end. So, start message and end message are the two messages we have written. In between the start and end, we are calling the main function. Now we see how it executes. So generally, to execute functions in the application, right inside the RAM, a memory will be allocated. This memory is called the stack memory. This is not only in a C language, but in any programming language, stack memory is common. In any function or any block, execute inside the stack memory only. To execute a method or block, some amount of memory will be allocated inside the stack. That is called a frame. A particular amount of memory will be allocated for every method execution. First time, whenever we start executing this program, operating system invokes the main method. So, we have a main method and a method frame that is created from the operating system. So, to maintain some memory, the first time, the main method, when it is invoked by the operating system, it is allocated some memory. This memory will amount to execute all the three statements defined inside the main method. Statement execution, printf, we are printing the method. This printf, a message start will be displayed, and afterwards the main function is being called. Now you will be asking a question, for this main method, will there be another method frame? Yes, there will be another method frame. You can see it will give another method frame in the forward direction, just like this. Again, the first statement printf start will be executed in this method frame, and then the main function is being called explicitly. This main function again will create a method frame in the forward direction, and this method frame will again execute its first function with the statement printf start. Next, the main function is called again. Now for this main function, another method frame will be created in the forward direction, just like this. And in this method frame, again there will be printf start, and then again main function is being called. Now, a time will come when all these frames will be created in such a manner that this entire stack memory is full, and there is no method to return for the control. There is no chance to come back and complete the execution of a previous frame. So it will continue to do so, and a time will come when the allocated memory will be full. Here it will be giving an error, that is the runtime error. Runtime error, or the out of memory error. It will terminate the program abnormally because sufficient amount of memory is not there. Since sufficient amount of memory is not there in the stack to continue the execution of your program, so that is a problem. So while working with recursive functions, one should be a bit careful while writing the logics, because in whichever order the control is going in the forward direction, in the same order the control should come back, and where it starts the execution, there only it should complete the execution. In such formats only we should write the program so as to avoid such errors or runtime errors. Let us consider another example of a C code where we have to find the factorial of a number using recursive techniques. In this function, we have declared in a fact function with the data type integer, and an argument that is being passed through it is also of integer type. Then we write the main function in which we declare a variable n and a res variable for the result. The next statement we write printf enter a number, and we accept the number using the scanf statement into the variable n. Now this n variable is passed as an argument in the function fact with the variable name res. It will calculate the result and then print the result of the factorial of that number. The next statement we are executing is printf factorial of n equals to %d, and res will be printed. This way the factorial of n will be printed into the inside the main function. Now whenever the function is being called, it will go to the function definition. First time the function is being called, it will be invoked by the main function or the compiler. Now inside the fact function, where we have passed an argument integer n, integer res we have declared as a variable. If n equals to 0, res will be equal to 1. Why we have done so? Because the factorial of 0 is a 1. Else the result value will be n into fact of n minus 1. And this value is being returned from this function. Basically, recursive function is calling function again from inside the function it is being defined. So let us see how this program executes in the coming slides. First time the main function will be invoked by the compiler or the operating system, where we have accepted the value of n equals to 4 and a variable res is being assigned to the function fact4. Whatever the fact4 value will be calculated, that will be stored into the res, and that will be printed once the execution is complete. Now since fact4 has been called, this will create a method frame in the forward direction for the fact frame. Now the fact value for fact function or the method frame for fact n equals to 4 will be created, in which it will check the condition if 4 equals to 0, which is a false condition. Since the condition is false, so the first statement will not be executed and the else statement will be executed, which says res is equal to fact 4 into fact of 3. This fact 3 will create another method frame in the forward direction. In this method frame, it will check the condition if 3 equals to 0, and which is a false condition again. So the first statement will not be executed and the else statement will be executed, which says res is equal to 3 into fact of 2. This fact of 2 will create another method frame in the forward direction with fact n equals to 2. In this, it will again check a condition if 2 equals to 0, which is again a false condition. So the first statement will not be executed and the else statement will be executed. which says res is equal to 2 into fact of 1. This fact of 1 will again invoke a method frame in the forward direction with the fact function n equals to 1, and inside this method frame it will again check the condition if 1 equals to 0. Since the condition is false, the first statement will not be executed and the else statement will be executed, which says res is equal to 1 into fact of 0. This fact 0 will again invoke a method frame in the forward direction with fact n equals to 0. Now inside this method frame it will check the condition if 0 equals to 0. Now this time the condition is true, and since the condition is true, the first statement inside this if block will be executed, which says res equals to 1. And in this particular method frame the result value will be returned, and so it will be res equals to 1 will be returned from this method frame. This res equals to 1 is returned to the method frame for the fact n equals to 1, and which says res is equal to 1 into fact of 0. Now since we have calculated fact of 0 in the previous method frame, now it will calculate result is equal to 1 into fact of 0, that is 1 into 1, which is equal to 1. So again res is equal to 1. This res equals to 1 will be returned from this method frame and will be returned to the function with the fact n equals to 2. Now res is equal to 2 into fact of 1. Now fact of 1 is we have calculated in the previous frame as 1, and this value of fact 1 will be multiplied by 2 to give the result 2 into 1, that is 2. Res equals to 2 will be returned from this method frame to the previous method frame now, which says res is equal to 3 into fact of 2. Now this fact of 2 is equal to, we have calculated as 2, so 3 into 2, now result will be equal to 6. This res equals to 6 will be returned to the previous method frame where the fact function is n equals to 4. Now inside this fact function there was result is equal to 4 into fact of 3. Now fact of 3 we have calculated as 6, so 4 into 6 will give me 24. This res equals to 24 will be returned to the finally to the main function, and this will be printed inside the main function where we have written the factorial of n is equal to res. So this res will be printed. So this is how a recursive function is being used to carefully move into the forward direction where the method frames are being called by calling the functions explicitly from inside within the function, and then the values are returned based on the iterative condition where we have to stop the function to move any to be called further. So this is how recursive function can be used to find the factorial of a number. The same program can be written in various other ways. Here we have seen we are writing this code inside the fact function. You can see that we have not used another variable. We are using we are not using any extra variable for this function to be executed. Like in the previous one we have said we are using we have defined an integer res, and then we have calculated the function and it will return the res value. Here we are directly returning the values. Like you can see, we are checking the condition if n equals to 0, then return 1, else return n into fact n minus 1. So here we are avoiding to write the extra variable res. There is one more method in which we can write this recursive program in a single line. The single line statement for executing this program. See, it has been marked with a green color inside the function definition, where it says return n equals to 0 question mark 1 colon n into fact of n minus 1. So this single line code means that it will return 1 if n equals to 0. The condition is true. If the condition is true, then it will return 1, else it will return n into fact of n minus 1. So this one line code can be used as a recursive code for this particular problem to be solved using recursive functions, that is for the factorial of a number. So this brings us to the end of this lecture, and hopefully all of you must have gained some knowledge about recursive functions and how to use them in your programming skills, and you can solve various problems based on recursive functions. Tower of Hanoi being one of them. I would request all of you to go and read about the Tower of Hanoi and how we can move the disks from one peg to another, to the third peg, and how many number of moves can be used and can be utilized, minimum number of moves that can be calculated using recursive functions. So if you have any problem regarding this video or anything regarding recursion, then you can drop me an email, or you can post it as a comment in the comment section below. Thank you so much.